Recently, a number of proposals started to investigate stateful forwarding abstractions in the fastpath, using a pipeline of many checksum tables as base model. Enabling the support for stateful forwarding in SDN data planes gives the ability to execute much more complex applications directly in the fastpath. A well-known of stateful network functions is the one supported by the Linux kernel and configured via iptables. This demo shows how a subset of stateful network functions can be implemented in Open Packet Processor, a recently proposed stateful data plane abstraction. OPP enables stateful forwarding support by giving SDN data planes the ability to execute extended finite state machines directly in the fastpath. An OPP pipeline consists of a configurable set of stateful and stateless stages. A stateless stage can be seen as a standard OpenFlow-like match action table. A stateful stage, instead, enhances the standard match action mechanism by providing the ability to associate to each processed packet a state context that is shared among all packets belonging to the same flow, and that can be dynamically modified by the data plane itself. An OPP stage handles each received packet by performing the following four operations. First, the packet is associated to a flow key by combining an arbitrary and user-configurable set of header fields. The flow key is then used to query the so-called flow context table and retrieve a state label and a set of data variables. Second, a set of user-defined algebraical conditions combining the values in the flow context and in the global context is evaluated. An array of the results of such condition is stored in the packet metadata. The packet header, along with the flow context and the condition array, is processed by the EFSM table, a match action table that, in addition to a set of packet actions, is able to associate to the packet a new label state and a set of update flow context functions. The set of updating functions and the state feedback is executed at the end of the pipeline stage. In this demo, we present three use cases that are executed in both software and hardware implementations of OPP. We assume a simple network topology consisting of an OPP switch that acts as an iptables router interconnecting of a private LAN and a DMZ with the public internet. In the first use case, the communication between the private LAN and the DMZ is allowed only for flows initiated from the LAN. The second use case shows the ability to perform a port forwarding to one of the available servers in a cluster according to a value of a global counter that is incremented upon the receipt of the first packet of a flow. All subsequent packets are forwarded according to the decision taken on the first packet, so that the forwarding consistency is assured. In the last use case, a typical dynamic NAT is implemented. For each first packet of a flow, a value of a free port is retrieved and the NAT binding is dynamically stored. For all the subsequent packets, as well as the packet in the opposite direction, the NAT binding is retrieved and the header field modified accordingly.